So welcome to my walkthrough for the Pearson Edexcel. As you can see, it's November 2024. We're on paper 3, higher, so calcs at the ready. And I know this one has a couple of tricky ones towards the end, but let's get on with the early ones. Number 1. So when you're drawing these graphs, the main difference is this is a frequency polygon, not a cumulative frequency polygon. Don't forget, cumulative frequency polygons have the well-recognized S shape. You use the upper class boundaries when plotting the cumulative frequency, but that's not what this is. So this one, when it's a frequency polygon, you should be using the midpoints. Otherwise, you lose one of the 2 marks. So you get 1 mark for getting all your heights correct, so 12, 28, and so on, and 1 mark for using the midpoints, and obviously don't do anything stupid like that. Any extra lines. I know there are some people join it up to 0, 0. No, not for me. Just join up the information you're given. Who knows what other information could do? Don't go beyond, don't try and do too much. Don't overcomplicate these early marks. Easy to lose some of these early bankers. Anyway, number 2. We've got a bit of standard form. When you are writing a number in standard form, or sorry, when you are trying to take a number out of standard form, my method is look at the power. It's positive, making this answer a large number. And if a number is large, these digits need moving over to the left. Now you'll have some teachers who will nag you that power of 6 means millions, and you can just work from there. And I'm sure there'll be some teachers that tell you, get a pencil and draw loops. So 1, 2, 3, 4, 5, plugging the gaps with zeros. Or, as I've said, power of 6 would mean million, so power of 5 means 100,000s. However you get there, it's only worth 1 mark, so it's entirely up to you. Stick with what works. Part B, writing a number in standard form. Firstly, I always advise my students, get that negative power in. This is a small number. And ask yourself, how many times do we need to move the decimal point, or indeed multiply by 10, to give us a number between 1 and 10? And the answer is, you only need to do it once. You would times it by 10 to get 8.026. And because you've only multiplied once, there we go. And as I've said, negative powers mean small numbers, small meaning below 1. Number 3, as you can see, can't do this with the technology I've got in front of me, so I've simply cut and pasted it from my model answers linked on my website. How do you do this if you're not sure? Set your compasses to any sensible distance. Mine is from that distance to there, as you can see. So spread your compasses. Anything not sensible would be longer than the line B to A, by the way. If it misses, a bit too big and too small, basically. And again, I always tell my students, draw yourself about a quarter of a circle, just about, so you get 2 new crossings. You then lift up your compass, plonk the metal bit on one of your crosses, get yourself another quarterish circle. As you can see, I do it quite small, about 1/8 or even smaller, doesn't matter, because as long as, pick up your compasses, as long as they cross, you've done it big enough. If they don't cross, make them larger. When they cross in this mid-air here, grab your ruler and join this new crossing with the vertex, and you've constructed your angled bisector. Number 4, pretty bog standard. Probability trees for your dance playing cards, etc. All we care about is the numbers. 0.3 for a win, must add up to 1. So 0.7 for a loss. we have no reason to change the numbers. Always look in the question. Does anything new happen? Is there a reason in the question to change these numbers? The answer is no. So keep them the same. Order is important. 1 mark for your first split and 1 mark for all the rest. Part B, work out the probability that Dan does not win either. Well, does not win. Lose, lose. It's bottom branch, and when you work down branches, you multiply said probabilities. Feel free to do mental arithmetic or grab your calculator. 0.7 times 0.9 results in 0.49. Number 5, we've got Robin. Now I've done this quite more extensively on the foundation paper because this was towards the end of the foundation paper. Feel free to go and watch that one for a slightly more in-depth explanation. I do it a bit more. I'll take a bit more time over there. Here, I'll just do the quick one. Robin pays 9p for a pen. She sells for 11. That's a 2p profit per pen, 4p profit per pencil. Let's go back to the question. Buys a total of 240. Well, you've got a calculator. 3 out of 8 of the shares are pens. 3/8 of 240. As I say, grab your calc. 3/8 times 240. That will tell you how many pens Robin buys, but by multiplying by 2p, that will tell us her profit. So the profit on the pens, 180p. Let's do pencils. 5/8 of 240, and they're making 4p each, means 600p profit, but more importantly, her total profit is £7.80 or 780p. To work out someone's percentage profit, you must work out, sometimes in the question they tell you the cost, they haven't here. So the cost of her pens, that's how many pens she bought. 3/8 times 240, and we times that, that's 90, by the way, and we times that by 9, so that's 810 pence on the cost. And the cost of the pencils, 5/8 of 240 is 150, times that by 6p, because that's her cost, and that means she is spending 900p on her pencils for a total cost to her of 1,710p. And if you've done it in pounds, so what, it's all good. Now we can move on and actually get on with the percentage profit. The formula for percentage profit is actual profit. That's the 780 we've already worked out, divided by original amount or original cost. That's what we've just worked out, and that's written now as a fraction. We want it as a percentage profit, so we times it by 100. Gives me 45.61%, but always do as you're told. 1 decimal place means we get 45.6. Quite long-winded, quite wordy. Take your time, take it nice and steady. 5 marks in the bag, hopefully. For number 6, we are comparing, as you can see, medians and ranges. You've got School B did the same test. School A, what have we got? Right, for School A, write down their range. There's 4 marks here. One's going to be for A's range because you haven't been told it, and 1's going to be for A's median, because again, you haven't been told it. So range is largest, 79. Take away smallest, that's 30. That means A's range is 49. And the statement you need, because that earns a mark, you now need a comparison. 49 is bigger than 47. School B, their range was 47. What does a bigger range or interquartile range means? It means it was more spread. So we've got 49 for A, so A's results were more spread or more varied. Is an examiner-friendly word. For A's median, obviously, you can do the old cross out the beginning, the end, the smallest, the biggest, and you'll work your way, hopefully, down to 57 being the median for your third mark. And again, you need a statement. 57 is better than 56. It's a higher score. They're doing a test. Higher scores will mean better results. So any of those words, better, higher, or whatever, as long as you now wrap it up with a statement, something on the lines of, try and get that phrase in. On average, A did better. Or words or phrases to that effect. But as I say, it's 4 marks. It's 1 for each bit of info you work out and 1 for each statement you use to make the comparison. Number 7, we have what's called a truncation here. The common mistake is to see 10.2, see that, and simply go up to 10.25 and down to 10.15. Neither of those values are correct, unfortunately, because that would be an error or a bound. All right, that would be an error interval in a bounds situation. This is truncation. It's been chopped off. It begins 10.2. End of conversation. The question really is, what could come after the 2? So there's her calculator screen. What's the lowest possible thing that could come after the 2? Well, quite frankly, nothing. Could be a load of zeros, in which case the calc wouldn't write it. It could just be 10.2. That's your answer for the smallest value of t. Using that on the flip side, what's the largest it could be? Well, it's 9s forever, isn't it? It could be 9s until the calculator runs out of space. Now, the mark scheme will obviously allow that, because that's the correct answer. Mark schemes, if you do type 10.2 onto your calc and press a load of 9s so that it scrolls off your screen, then hit equals, it will write 10.3. But that's the answer I'd be writing. I'd say that's the perfect answer, but the mark scheme does also allow 10.3. Anyway, on to part A. You've got an angle, you've got a side, it's SOHCAHTOA. Get on with your labels. We want to work out AB. I'll always call it X, but it's also the opposite side. 7.6 is adjacent, and it's the hypotenuse that we are not bothered about. So by H being rejected, this is a TOA question or a TAN question. I always use the cover-up method. We want the opposite, cover it up. This now becomes a multiply. It's tan 62 multiplied by the adjacent 7.6. If you don't get 14.29, which becomes 14.3 on your calc, when you do as you're told. If you don't get that, be careful with your calculator. If you've got one of them smart aleck calculators that opens brackets, you must make sure you close it. And I know some students, they don't trust their calculators at all. They do the 7.6 first. And if you're still not getting 14.29, you need to consult your manual. I'm afraid it's not in degrees mode, it's doing something else. On to number 9. Number 9 is laws of indices. When you are multiplying laws of indices, you add the powers. So deal with the numbers first. 2 times 7 gives us 14. Now let's do the x's. Add the powers, that's a 3 and a 2, giving us 5. Add the y's, but they've been sneaky. There isn't a power there, and if there isn't a power, yes there is, it's a 1. Adding a 5 to a 1 gives us 6. 2 marks, although you've got 3 things to do, you will lose a mark for each mistake. So if you make one mistake, if one of them isn't correct, 1 out of 2. If 2 of them are wrong, I'm afraid it's 0. And part B, when you've got a bracket, that's a power to a power. That's the multiplication of the powers. As I've said before, mental arithmetic's fine. Use a calc if you hate minuses. 2 times -3 gives us -6. Number 10. In a sale, the normal prices are reduced by 15%. So we do not know the original amount. Yep, this is your old friend, reverse percentages. Everyone's got their own way of how they set these out. The way I think about it is, first of all, get the first mark by writing the multiplier. If you reduce something by 15%, your multiplier is 0.85. You take the 15 pence away from a pound. Something has been multiplied by 0.85 to give the new price of £46.75. And as we know from reverse percentages, I'm sure you've been revising it, it's called reverse because it's one of those where you don't multiply by your multiplier. You divide by your multiplier because you're working backwards. And hey presto, we get £55, which is a perfectly reasonable sounding starting number. Number 11, it sort of switches, I think, at this stage. This is where it starts to become a little bit tricky. We're into that trickier middle territory now, but keep on going. The sector has perimeter of. Stop right there. If that radius is 4.7, the perimeter, which is all this Pac-Man shape, will include 4.7 twice. So just be careful. What that means we can do is we can do 34.3, take away the two 4.7s, which is 9.4. That tells us that the length of the arc is 24.9. And once you've got the length of the arc, there we go. We can start worrying about how to work out the size of this angle, because there is a formula for the length of an arc, which is basically the formula for the circumference of the circle, 2 times pi times the radius. That gives you the full circle, but we haven't got a full circle. We've got a fraction of a circle, and that fraction is x. Out of a full circle would be 360 degrees. And it's that formula there which gives us the 24.9. It's now a case of get that calculator grabbed, do everything backwards. Start with your 24.9, multiply both sides by 360, divide both sides by 4.7, divide both sides by 2 pi. Your value of x should end up 303.5 and so on. So when you round that off, 304 degrees. On we go. We've got a savings, and it's that bit like the reverse percentages a couple of questions ago. Write down your multipliers. If you are increasing by 2%, your multiplier is 1.02. But there's a 4 on the end. Let's stick a 4 on the end. Do the same for 1.8, 1.01 with an 8 on the end. It's 2.4 for the first year, 1.8 for each extra year. 3 years means that needs a little 2. As I've said on the previous question, grab your calc, 4,500 times all that, and I'm usually with money, 2 decimal places is where you want to be. So £4,775, 38 pence. Next, we are buying a car. Bruna is buying a car for £7,500. Now, I don't like using X%. I'm going to say that £7,500 times by an unknown twice is 4,107. There's your equation set up. Get it solved. Divide both sides by 7,500. 0.5476. And to get your y, your multiplier, you square root it. And as I said in a few questions, that's not your answer. You haven't finished. Y is the multiplier. So this 7,500 has been multiplied by 0.74 twice. If you're multiplying something by 0.74, you are reducing it. You've took 26 pence off the pound, which means a reduction of 26%. Number 13. I know some people will swear by if you've got what's essentially 2 triangles overlapped. I know some people that much prefer to draw a totally separate. Separate the diagrams and go from there. And that's very worthwhile. If that's what helps to get you the right answer, go for it. But I'm not going to do that this time. I'm going to just leave the diagram alone, get this information on there, and then see what the score is. B to E is 4.2. CD, 6.3. Stop right there. I can work out a multiplier straight away. My scale factor to go from small line to large line is 6.3 divided by 4.2. In other words, the scale factor, the multiplier, is 1.5. Now, if you've chose to go from there to there, if you've done 4.2 divided by 6.3, that's fine. You've just got your multiplier. That just means 2/3. It's fine. Doesn't matter. AC is 10.8. That entire line is 10.8. Work out the area of the trapezium BCDE. Well, this is a trapezium. If you want to work out the area of a trapezium, you add together the parallel sides and halve them. You then multiply it by the height of the trapezium. The height is defined as the perpendicular distance between the two parallel lines. In other words, I want that value, oh, I've called it x there, I should be calling it h. I want that distance h. Well, the good news is we can work it out. If we do 10.8, which is this whole line, if we divide it by our multiplier, because we're getting smaller, we can get the value of a to b. So that becomes 7.2. In it goes. If a to b is 7.2 and a to c is 10.8, h is the difference between the two. In other words, 3.6. Onto your calc. Grab your calcs, use the brackets sensibly, and you'll get the answer of 18.9. Job's a good one. Number 14, prove algebraically. In other words, put your calc away, put it to one side. Yes, you're on a calc paper. They don't care. You'll have a couple of different ways. Some teachers will say to you, whatever number you've got, call it x. Times it by 10, then 100, then 1,000, and see where you are. And that's perfectly valid. For me, though, I always times it by 10 first of all. Whoops, don't need the 0. 4.62 forever. Now I want this 62 forever to be in this number as well. And the only way is if I multiply by 100. 10x times 100 means I actually need 1000x. I don't need the 100x step. But if you've done that, that's fine, not a problem. We get 462.62. We now do a big takeaway, bottom minus top. 1000x take away 10x. 462 point something minus 4 point the same something. The somethings cancel out. And there we go. We now divide by the number next to x. We get 458 over 990, which we can be sure. This is where you can grab your calc to make sure you've got the right numbers. We do indeed get what we've been given, and there we go. So for number 15, we've got that changing the subject, sometimes called rearranging, sometimes called transposition of formula. At the end of the day, to make P the subject, we want the answer to say P equals. So let's get on with it. One of those difficult ones because there are a couple of P's in the equation, and that ultimately means at some point you're going to have to factorize. But before you start thinking about that, level it off, get it on a level, multiply both sides by 5 minus 2p. If you are the sort of person who would have expanded that straight away, that's fine. I'll just do that extra step. So now let's expand the brackets. Doesn't matter if you write TP or PT, no one cares. But now comes the key step. To get P equals, you want all the P terms on the same side. You could, through habit, choose to get them on the left, but I'm going to go for the right-hand side here because I prefer to avoid negatives. I'm going to add 6 to both sides, whilst at the same time adding 2pt to both sides. Now's that stage I mentioned. Take the p out, factorise for p. And we're there. Because to isolate p to get p on its own, we simply take the 5t plus 6 and divide by whatever is next to p. Now if, at that stage, you chose to take the p's to the left-hand side instead of the right, it's absolutely fine. It just means ultimately you could end up with the answer where every sign here is different. It's just a minus where you see a plus and so on. It doesn't matter. On we go. Number 16, not a fan of this question. I think it's quite a tricky one and it's quite early on for the final part of the. This should be like the final question for me. Don't like it. Anyway, let's shut up and go on with it. We are told where B is. It's at the coordinate 2 minus 4. Stop right there. That means we know its gradient. Gradient is change in y's, that's down 4, divided by change in x's, that's plus 2. If you do minus 4 divided by 2, the gradient of OB is negative 2. That's important because you're told it's a rectangle. That means we have right angles everywhere. But in terms of gradient, we can do a negative reciprocal, flip it and change the sign. The gradient of OD and BC, therefore, is, whoops, I've written a negative, change the sign, my apologies, it's positive a half. Once you've got that, you can start getting now into the real meat of the question. We're told where E is. 12 minus 6.5. The vertex we don't really know anything about is C. I'm going to call the coordinates of C X and Y. Now, I don't want to call D X and Y because we'll get there in a bit. What do we know about C? Well, C lies on 2 straight lines. And that's important because where 2 straight lines cross, you can find X and Y by using simultaneous equations. It's just we need to come up with those equations. So let's do it. The equation to where we're going to get it is simply using the formula for gradient. Let's say we can make the statement that the gradient of BC, which we know is positive a half, is given by doing change in y's, y minus 4, over change in x's, x minus 2. So let's just rearrange that. Let's just double both sides and times both sides by x minus 2. And now we can slightly rearrange. We can make the statement that x equals 2y plus 10. We have one of 2 equations. We can do a similar approach now for the gradient of C to E, this line here. The gradient of C to E, because DCE are a straight line, their gradient is negative 2. And the formula to find the gradient is change in y's, so that's y minus 5, all over change in x's, that's x minus 12, Same mucking around, times both sides by x minus 12. I end up with minus 2x plus 24 equals y plus 6.5. And as we know, we can just slightly rearrange. I can say that 2x equals minus y, because I'm just changing all the signs, plus 17.5. There we go. We've got our simultaneous equations. I can double both of these. If I make that 2x, that will be 4y and 20. Let's equate, double that, and put it equal to that. Minus y plus 17.5 is equal to double whatever x is, 4y plus 20. We can now rearrange to find y. Adding y to both sides. Subtract 20 from both sides. Grab your calc if you need to, but we get y is minus 0.5. And if we go back to an original equation, x equals double the y value, that gives you negative 1, plus 10, we get the value of 9. Now let's go back to our graphic. We know that we can get rid of that because actually the coordinates of C are 9 along and 0.5 down. What do we know about rectangles? We know that the journey from there to there would be the same as the journey from 0, 0 to there. So there's the question. What is the journey? Let's do that in a different colour to try and... Come on, slow coach. Horizontally, it's gone from 2 to 9, so it's 7 to the right. Vertically, it's gone from minus 4 down to minus a half down. That means it's gone up 3.5. 7 along, 3.5 for that line. Start at the origin, 7 along, 3.5 up. That's where D is. D is 7 along, 3.5 up, and I really don't like that question. So after that debacle of a question, we get some reasonably straightforward trigonometry. So we have a non-right angled triangle, so all your SOHCAHTOA, I'm afraid, Pythagoras, nope. It's your sine rule, cosine rule, and because we want the area, it's going to become a half AB sine C. You could pick any angle you want, because in order, if we work backwards on this logically, to find the area, we're going to need to do a half AB sine C, and that's any two sides with the angle that's between those two sides. And that's the bit we don't have. So back to the diagram. If you want to find the angle there or there, you're perfectly welcome. But for me, I've chosen that route. Let's call it X. Now you can either use the cosine rule as is, or use the rearranged version. You might have had that nagged into you. It's entirely your choice. But as long as you end up with 103-ish degrees, it's all fine. But let's get there. Here we go. I'm going to use the cosine rule standard. The angle that's opposite the angle you want is equal to the other two sides squared and added minus 2 lots of the same two sides multiplied together times by the cos of the angle that's between these two sides. In other words, for me, it's x. And however you choose to rearrange that, it's entirely up to you. I just get my calc to do it and do opposites. Start with 18.2 squared. I would subtract that, divide by all that. Hit equals, hopefully you get minus 0.2413-ish. If you don't, double check it, but insert some brackets if you don't get that. As you can see though, that's not an angle. You need to inverse cos it. Should give you the angle I mentioned earlier, 103-ish. Leave that in your screen so you can utilize the A&S button and the angles, the sides, either side of this angle are 14.6 and 7.9. So they're the two sides you're going to use. 14.6, 7.9, and the sine of the angle between them. Use your A&S button. We end up with 55.96, but doing as I were told, 56.0 for three significant figures. Number 18, a lesser known topic, quite a new recent topic. It's called capture, recapture, and it's nice when you know how. There's lots of different ways of setting them up, but here's how I go about it. Maria, on Saturday, she catches 40 frogs out of an unknown number of frogs. There we go. On Monday, she recaptures, and the ones that have been tagged are 11 are recaptured twice out of 55. Some teachers I know will set this up as a multiply, but each to their own. At the end of the day, you've got your calculator, multiply both sides by n, both sides by 55, and when you divide both sides by 11, you get a sensible sounding population of 200. Now, part B, there's lots of different ways you could attack this. State one assumption you've made. You could say that the frogs recaptured represent the population. That's quite a standard way, but I prefer to go for a slightly different way, in that we're assuming that all of the tags stayed attached. Could easily have wriggled free, the little slimy things, but something along those lines, something could have happened with the methodology. And I think the main thing there would be some of the tags might have come loose. Obviously would affect your estimate of your answer. Number 19, one of these equations where it feels like you don't have enough numbers to work it out. But don't worry, you absolutely do. My advice with these questions, as always, just track on. Just track on as if they've told you the radius and the height, just with letters instead of numbers. Now, when you look into your cones, you'll know that the perpendicular height of the cone and the slant of the cone do indeed give us Pythagoras. We can therefore relate them, because if we're going to work out surface area, we're going to need to work with the slant length, not the height or the radius. We need to work out the slant length in terms of either R or H. Entirely which way you want to go about it, but the way I went about it is, if we call the height H, the radius is 3/4 of that, Let's call it 3/4 h then. Now we can proceed with Pythagoras to find the slant. Square both sides. 3/4h squared. The slant is the hypotenuse, so it's an add. And we're going to be needing to square root because slant is L. We're going to need to square root all that. I would advise you to grab your calculators because it's really a fractions question. You've got a h squared there and a h and 1h squared here. It's the coefficients, it's the numbers next to it you need to grab your calculator for, because you've got 3/4 squared added to 1 squared. 3/4 squared is 9/16. 1 squared is 1. 9/16 added to 1. Grab your calc if you need to. It's 25/16. And we can indeed square root the top, square root the bottom, and square root the h squared. There we go. That is our little term representing the slant length. The slant length is 5/4 of the height. Let's now crack on. Total surface area is 54 pi. The total surface area, total including the base, will be pi r squared r, don't forget, is 3/4 h. So that is my base, pi times the radius squared, added to the rest of the cone. That's the curved surface area of the cone. There's your formula. Pi times r, which is the radius, times by the 5/4 h there. And as always happens with these questions, get rid of the pi's. Every term's got a pi in it. You can divide everything by pi. We've got 54 on the left-hand side. On the right-hand side, we've got h squared with a 3/4 squared next to it. In other words, 9/16. And we've got h times h, more h squared, except next to it is 3/4 times 5/4, which is 15/16. They become quite easy to add together. We are getting, 15 plus 9, 24/16. And our job now is to work out h squared. You need to take 54, stick it in your calc, times by 16, you get a big number, 864 I think, divide by 24, and guess what? You get a lovely, nice, easy looking answer. Square root of h is 6. Yep, not -6 though. We ignore the negative because we're talking about lengths. On we go. Number 20. Yep, one of those top-end simultaneous equations. Few ways of doing it. You could substitute, you could rearrange the bottom equation to be x equals and stick it in. I'm not though. I'm going to take the bottom equation. If we subtract 2x from both sides, we get that. But then if we square both sides, we get that. The top equation tells us y squared equals that bit. The bottom equation tells us y squared equals that bit. We can make the statement that these two bits, that's the 3x squared and the 4, is equal to the 7. And it now becomes an expand, collect like terms, get equal to 0, find your values for x. Let's square the right-hand side. Square the first, square the last, times the two together and double it, we're getting negative 28x. We now want it to be equal to 0. Subtract 3x squared from both sides. Nothing to do with the x's, just leave the negative 28x alone. We now subtract 4 from both sides. We get 45. Sometimes these factorise nice and easy, these don't. Get your quadratic formula. A is 1, B is negative 28, C is 45. So your quadratic formula should be looking like minus B, so change the sign. Square root of B squared becomes 784 minus 4 times 1 times 45 all over 2. This is where I'm a big fan of splitting your page. Grab your calc, do 28 plus the square root of all that, hit equals before you divide it by 2. I get 26.2882, and when you do the minus, I get 1.7117. Mark scheme worth a note. Sorry, the question does say 3 significant figures, so you should be maybe rounding that off to 26.3 and 1.71, but it's entirely up to you. I always do it at the end. Pick one of the original equations. I'll use the bottom one because it's the easiest. The y coordinate must equal 7 minus the x coordinate double. So y must equal 7 minus the x coordinate doubled. And that should give you the horrible looking minus 45.57-ish. Do the same over here. 7 minus 2 lots of whatever answer you wrote down, and I get 3.5764. And worth noting, it's not set in a way that should be coordinates, so don't give your answer as coordinates. Okay, none of that. Don't be idle. Write it out in full. When x is 26.3, y is minus 45.6, and when x is 1.71, y is 3.58. Yeah, normally they're a little bit friendlier than that. That one, not so. 21a. What you've got is an entire function has been multiplied by -1. What that means is the outputs, the y's, all change signs. So if it's a positive y, it reflects to be a negative y, otherwise known as a reflection in the x-axis. That looks like a Q. Wrong, come on. Axis. So anything above, 3 above becomes 3 below. 2 below becomes 2 above, 3 above becomes 3 below. Oh, what am I doing? Do apologise, folks. This is my first video back this year, by the way. Happy 2026. Wrong! 3 above means 3 below. That's better. 3 above means 3 below. Grab your ruler, make a proper job of it. Hopefully yours looks better than mine. What am I doing? I do apologise. 2 above, having an absolute mare. Well, I've got there in the end, let's say. Oh dear, I've got there in the end. There we go, thank God for that. On to the next one. Hopefully make a better job of this. Part B, you've got the sine curve. It's asking us to translate it. There are two translations gone on here. A +4 on the end of an equation moves a graph up 4 units. Vertically, it's the correct way around. This, though, is horizontal, and horizontal is the opposite way to what you'd expect. So by putting a +180, that would actually be moving it left, or in -180. The point P, where is it currently? So hopefully you'll know that's 90, that's 180, that is 270, and its height is -1. Well, if your height is -1 and you're moved up 4, you end at 3. Horizontally, if your position is 270 degrees to the right of the origin, you're moved left 180, you'll end up 90 degrees to the right of the origin. Yes, I did much better on B than part A. Number 22. If we're estimating the area under a curve, 3 strips, 0 to 30, you need to plonk your strips in. They don't need to be perfectly neat or anything. No one cares. What's most important is that you show the examiner what's going on. I know a lot of teachers will make you do that, and I totally agree. What we're interested in is these heights. That height is at 54. That height is at 76. And that height, just over the 90, is at 92. To work out the area of each shape, or the first shape is a triangle, and B and C are trapezoidal. So let's crack on. For A, it's a triangle, it's a half times the base of 10 times the height of 54. Grab your calc if you need it, 270. Part B is a trapezium, it's a half of the parallel sides added, multiplied by the distance between them, which is also 10, because they should be all 10 if they're equally spaced. You are told to do so. Gives you 650. Same for C, also a trapezium, half, and this time it's 76, and the 92 you can just see at the top, giving us 840. Get all them added together, and you've banked a nice easy 3 marks, 1,760 metres. And number 23 for a finale. Now, horrible looking question, I grant you. Showing as soon as you see the phrase turning point, you should be completing the square. And it looks horrible. Don't get put off. The method for completing the square is halve the bit in front of x, in this case, negative 6p. Halve it. Whatever that is gets squared and subtracted. That's the key. Now, what do we complete the square for? We complete the square because whatever this value is, if you change the sign of it, you get the horizontal coordinate of the turning point. And whatever comes at the end is the vertical or the y coordinate of the vertex, or the minimum or the turning point. So that's where our turning point should be. And there's no scale required. It does not ask for these solutions. No one's interested. The examiner's not either. They're interested in getting what I've just put on there. We've got the shape, we've got the coordinates of the turning point, we're up to 4 marks. It does say, and the coordinates where it crosses the y-axis. There we go. Go back to the original equation. It ends with a -7. The y-intercept is at -7. As I say, that was a tricky question. These weren't bad. If I'm honest, I thought it was the stinker, in my opinion, came much earlier. I thought number 16 was the rotten question. There's tough questions after that, but for me, 16's horrendous and 23 is non-standard. So I'm sure some people found that very tricky. The rest, good meaty questions to attempt for revision. Anyway, good luck revising. Hope that's helped. See you on the next one.